So now our next topic is the angular acceleration. In the previous video we discussed about angular velocity. Now let's talk about that what is angular acceleration. Okay, so angular acceleration is the vector quantity, which means it is having a magnitude and direction too. So what is angular acceleration? The rate of change of angular velocity is called angular acceleration. In the previous video we discussed about that what was the angular velocity. The rate of change and displacement is called angular velocity, but here the rate of change in the angular velocity, that is called angular acceleration. So here you can see that the angular acceleration denoted by the alpha here like this, and it is equal to the rate of change of what? Angular velocities. As you guys all know, an angular velocity was denoted by the omega in the previous video. If you haven't seen that, so first of all watch that video, so it will be easy to understand. Okay, so this is omega, rate and change of you can say that the angular velocity with respect to the rate of change of means time is there, so which means time, the rate of change of, okay, this is change, rate of change of. So here you can see that alpha is equal to rate of change of is there, so which means the final minus initial. So we can write here that the omega final minus omega initial upon t, which is equal to the rate of change. Okay, so if you talk about the SI unit, so SI unit of, you can say that this angular acceleration, so that is if we are having a formula, that is rate and change of, we are having this formula of the acceleration. Okay, so if we talk about this, so as you guys all know, in the previous video discussed about the SI unit of angular velocity was radian per second. So we can write here the angular acceleration is equal to the angular velocity formula. We were having a radian upon second upon, we are having time, so the SI unit of time is second. So second is second square, so we can write here that the radian upon second square, this is the SI unit of the this. Or we can write, if the radian is not there, okay, if radian is not there, which means an answer there and radian is not considered, so we can write only s square. So here you can, it is downward, it will move upward, it will get negative, so we can write here this. So this is also the unit of the angular acceleration when radian is not appear in the final answer, so this will be the angular acceleration unit. So now if we talk about the direction of the angular acceleration, as you guys all know in the previous video, the direction of the angular velocity we consider by the right hand rule. So this is also having the same concept but little bit changes there. So let's see what the change is there. So direction of angular acceleration. Okay, so what does it mean? Acceleration, the rate of change of in velocity, that was the linear, but here we are considering angular, so we can say that the rate of change of angular velocity is called the angular acceleration. Okay, so for example, I'm having two wheel which are moving with you can see that with the right hand rule, as you guys on a previous video discussed about that, this is, we always denoted by the, in the x-axis, we always see the direction by the x-axis, and we were having a angular velocity 2, angular velocity omega was 2. Okay, so now in this video we discuss about that the how to identify the angular acceleration. Okay, so when the, you can say that when the angular you can say that when the angular acceleration is increasing, okay, angular when, for example, when the, you can say that the angular velocity is increasing as well as the angular acceleration is increasing. Okay, so that means that this is the increasing angular, this is the increasing angular velocity. which means that if the angular velocity is increasing, which means that the angular acceleration is also increasing, so which means it is having a parallel direction. Okay, when if the you can say that the angular velocity is decreasing and you can say the angular acceleration is increasing, so it means that this is anti-parallel, which means that the decreasing of angular velocity. Okay, so this is the, as you guys all know, according to the right hand rule, this was the outward direction, that this you can say that the anti-clockwise, so this is outward with the help of the right hand rule. As you guys all know, if we're talking about this, so this is the direction, this side. Okay, so this was the inward. Okay, so we can write here the acceleration and velocity are parallel to each other if velocity of a body increase as well as the angular acceleration of a body increase. Okay, and when the acceleration is opposite and velocity is, like, you can say that the angular velocity is, or you can say the decreasing, and angular acceleration is increasing, so which means that the angular velocity direction is the inward and this is the outward. So through this basically you can say that the why I'm telling you guys about the angular velocity, just because the direction of angular acceleration just depend upon the direction of angular velocity. That if the angular velocity is increasing, which means that the angular you can say that acceleration is there, but it is increasing too with that. If the angular velocity decreasing and you can say the angular velocity decreasing, which means that the angular acceleration is increasing, which is anti-parallel, so which means that the angular acceleration direction is, you can say that, inward, and it is having a decreasing of the angular velocity. So through this you can identify the direction of the angular acceleration. So this was about the angular acceleration. In the next video we will discuss about the relation between the linear and angular quantities.